we look at, first we need to define the decision variables in a way that we can write the objective function out without any logical condition. Okay, so we define those two groups, and then we try to identify the relationship between these two. Okay, and then we came up with two different ways of forcing the x11 and 12 value. I encourage you to do the other way, see if you can work that out. But we start with this one because the x12, which is like the condition here, the base condition, includes all the situations. Okay, just by looking at it, it's more meaningful. And from there, I start to look at, okay, this x11 value need to be equal to a value, but in another situation, let's say equal to this value. Okay, and with that, talking about, okay, if we want to force a value equal to something, put constraint, put that value, multiply a binary variable on both sides or one side, and we work on it to check if it works. And we found one of them worked for both situations that we want to achieve for our x11. Okay, and then we think, okay, see, x11 situation can be achieved with this y value. But because x11 situations are related to the x12, so we want to use this y to link the x11 and the x12 together. Okay, and then we look at, okay, what's the thing that we want to achieve? It's like when y equals to 1, you need this to be greater than 0. When this is 0, you want this to be 0. Then we think about, oh, that's similar to the fixed charge problem in a similar way. So we came up with that constraint we used in the fixed charge problem, tested it to see if it worked. Worked for one of them, but didn't work for the other. Then to add the other side of the constraint, we figured this out. And that's the constraint that we need to use. Okay, and these two constraints are formulated based on this logical condition here. Okay, but similarly, with the help of the model and objective function, we don't need some of them. We don't need the other side. Okay, so these are the model that constraint we came up with. Okay, but those ones that highlighted with a star, for example, this x11 less than equal to 75, this less than equal to 50. These ones, they don't need to be here in this model, which means if you don't have these 1, 2, 3, 4 constraints, the model still work. And the reason is that based on the resources. Okay, think about it. x11 represents the first 75 units of equal spots to produce. Okay, and comparing x11 and x12, they use exactly the same resource. Okay. Oh, another thing I didn't talk about is for the constraint, you do need to include both x11 and x12 to represent correctly the resources needed. Okay, so but looking at that, x11 is making only 350 profit, and x12 is making 375, which means that producing x12 is more effective, more cost effective. Okay, if we don't have any constraint to limit them, x11 will not start to increase. Okay, does that make sense? This will not start to increase from 0 unless we force this x11 to be a value here, because it's just not effective to produce this x11 as compared to x12. Okay, and the same here. So if you look at this one and this one here, these two we don't need, because x11 will not, we don't need to set, what this constraint is, we are setting upper bound for x11, but we don't need it, because x11 is not going to increase anyway, because it's just not effective. So we don't need to set the upper bound for it. Same as x12, because it is so effective comparing to x11 to produce this starting from the 76 unit. If we don't need to set a lower bound for it, it will increase. What we want to force is only the other side. Okay, we want to force x11 to be equal to 75 if we start to produce this. and we want to x12 to be equal to 0 if we are not producing the first 75 units. Okay, so this is just, I think like the way that we talk about in class is much easier and help you practice your logical thinking and transfer them into constraints. Okay, but being learning operational research also means sometimes, especially if you're dealing with complex problems, knowing what the problem works, how it works, will help you reduce the complexity of the model. For example, here, if we reduce these constraints, it takes less time for the problem to solve. Okay, so with less constraint, the problem will solve faster. Okay, any questions?